Hello everyone. So based on popular demand, as many of you asked me to do that, so I will start LTE KPI optimization session as well. So today will be our first session on LTE KPI optimization, and we will discuss about ERAB setup success rate KPI. Now ERAB setup success rate KPI is a part of LTE accessibility, but in order to understand the KPI and how to optimize that, we need to understand the call flows. So let me go through the call flow first. Okay, so let's say we have a mobile, an E node B, LTE E node B, and the MME, which is the LTE core. So what happens during the initial call flow, during initial accessibility? The UE will first send a random access preamble, also called message 1, also known as the RACH. So once the UE sends the RACH, the E node B will get the RACH and respond with random access response, also known as RAR or message 2. The RAR or message 2, this is the message which carries the TA, the timing advance. Now the UE gets the RAR, reads the timing advance, and sends message 3 based on the timing offset after adjusting the timing offset. And this message 3 is actually the RRC connection request. And this is where the E node B will peg RRC attempt. Now the RRC connection request will carry the cause of the connection, which can be like MO signaling or MO data or MT access or other causes are also possible. So based on this, the E node B will respond back with RRC connection setup. And once the UE gets that, it will send the message 5 RRC connection setup complete, which completes the RRC success. So the E node B will peg RRC success at this point. So this message carries, if you have a NAS, if you are using a tracking area update for instance, so this is the message which will carry the NAS PDU, the NAS part of the message. So once the E node B gets that, it needs to send it to the core, and that is done with the message S1 initial UE message. MME reads this, it finds out about this UE, specific UE, and what this UE wants, and what is the requirement for this UE, and then MME sends S1 initial context setup request, which carries the context and the response to the UE's initial request. So once the E node B gets this, at this point E node B pegs ERAB attempt. Now E node B gets this, but it needs to transfer this information to the UE, and that is done using two messages: security mode command and RRC connection reconfiguration message. So for instance, if this message carries information about QCI 9 for instance, then RRC reconfiguration message will carry the QCI 9 data radio bearer information for the UE, so the UE can actually add the QCI 9 bearer over the air. So this is how these messages are relevant. Now once the UE gets that, the UE responds with the security mode complete and RRC connection reconfiguration complete. Now E node B gets this message, and at this point E node B then sends S1 initial context setup response, which is the response to this message, and at this point the E node B then says that now the ERAB setup was successfully established. So the KPI for ERAB setup success rate will be ERAB success divided by ERAB attempt. So this was the call flow. Now there can be many causes of a degradation of this KPI. So let's look at some of the most important and most common causes, and then understand one by one how we can handle them. So one of the possible causes is that once the E node B gets S1 initial context setup request, then it sends security mode command and RRC connection reconfiguration command to the UE. The UE can respond back with a security mode fail. Now if that happens, then the E node B will respond with S1 initial context setup failure to the MME, and we will have an ERAB setup failure. Now why it happens? It happens sometimes because sometimes there are UEs that do not support security mode command and RRC reconfiguration to be bundled together. So if that is the case, and if you have this issue a lot in your network, then what you can do is you can ensure that you transmit the security mode command and RRC reconfiguration separately and do not bundle them together. This, if you do that, then most of the cases this issue gets resolved. Now another issue is the problem where the E node B gets S1 initial context setup request, and then transfers that over a security mode command and RRC reconfiguration, but the UE does not send any response. So the UE does not reply back with a security mode complete or RRC connection reconfiguration complete. So that a timer on the core or on the inode B expires, and it sends the UE context release to the MME, and at this time we also have a ERAB setup fail. Now, what can cause this scenario? One can be a possibility that the UE has gone into bad coverage, such that the uplink is not reaching the inode B anymore. It is also possible that it's another problem that sometimes during RRC reconnection reconfiguration, we change the scheduling request indicator configuration. So if we do that, some UEs do not support it. So why is it important? Let's understand that. In RRC connection setup, we tell the UE where to send its scheduling request. Now, if over here, due to load or any other feature, we change that and tell the UE to send it the scheduling request to at another place, and the UE does not support this change, then it will keep sending the scheduling request based on the last known information, which is over here, while the enode B will be expecting it by the new information which is sent in this message. So the enode B will not respond to the scheduling requests, and the UE will keep sending it at the old location, and in that case nothing will be sent by the UE, or enode B and UE will not be able to really communicate in the uplink. So we'll see a no response from the UE. So if you're having this issue and you have some feature enabled which can adaptively change the scheduling request indicator, then try disabling it and see if that improves. Okay, another issue would be RRC reestablishment. Now let's say enode B gets the S1 initial context setup request. It sends the security mode command and RRC connection reconfiguration to the UE. UE reads that, but somehow the UE has a radio link failure, and it tries to do an RRC reestablishment. In that case, for RRC reestablishment to be successful, the UE must have security mode activated. Now, as far as UE is concerned, it has received the security mode command, so it thinks that it is activated on the UE side. But the enode B has not received security mode complete command, complete message from the UE. So enode B thinks that this one, the security mode, is still not activated. So when the UE sends an RRC reestablishment request at this point in the call flow, the enode B rejects it, saying that your security mode is not activated yet, so you cannot have an RRC reestablishment success, because from the enode B's perspective, the context is still not active for this UE. And for RRC reestablishment to be successful, the enode B must be sure that the context of the UE is active. So in this scenario, the RRC reestablishment will be rejected, and the enode B will send S1 initial context setup fail to the MME, causing an ERAB setup fail. Now, if this is the problem that you're facing, then in many cases there are implementations where we have a support for RRC connection reestablishment request even without security mode to be activated. So if we enable that feature or switch, for instance, then we should be able to see improvement in this scenario. Another aspect would be to reduce the radio link failures, and for that to happen, we can increase like say N310, T310. That can reduce the RLF count. We can increase RLC transmission count. That can also reduce the RLF count. Or we can focus on improving our channel quality and optimization. Optimize the area to improve our SINR and quality. That can also reduce the radio link failures. Now, these are the causes that are pegged as RAN initiated ERAB setup failures. Now, let's have a look at MME induced ERAB setup failures. Now, important thing to understand is that MME induced ERAB setup failures are usually also caused because of RAN, because of radio interface, but it is somehow pegged under MME because the enode B does not know that the radio interface has undergone a radio link failure. Let's understand that. Now consider this scenario where the MME sends in S1 initial context setup request to enode B1. Now eNode B1 sent a security mode command and RRC connection reconfiguration to the UE. But before the UE actually reads this, UE has already lost the radio link. That means the UE already had a radio link failure before it could read these two messages. So what will happen? UE will attempt a new RRC connection request. So let's say the UE attempts a new RRC connection request on eNode B2. Now on eNode B2, it will start a new RRC setup, just like the call flow we discussed. So once the RRC setup is complete over here, uh, then eNode B2 will send an S1 initial UE message for this UE to the MME. Now MME will read this message, it will read the TIMSI of the UE, and it will think that this UE is already undergoing an ERAB setup from eNode B1. So what it will do is that it cannot have two active contexts for the same UE. So it will send a UE context release command to eNode B1, and it will send an S1 initial context setup request to eNode B2 to set up a new ERAB for this UE on eNode B2. Now eNode B1 will think that it is setting up an ERAB for this UE, and because the MME sent me the command of context release for this UE, so it is not my issue, it is a MME issue. It will peg an MME induced ERAB setup failure, and then it will respond back saying S1 initial context setup fail because MME asked me to release the context, and it will peg a ERAB setup failure. So what happened actually is that the UE had a radio link failure. It tried to connect to another eNode B, and when that eNode B tried to connect that UE to the MME, MME released the first context on eNode B1, and eNode B1 thought that the context release from the MME is an MME induced ERAB setup failure. Well, actually it was a radio link failure over here. The eNode B1 just did not know about it because there is no messaging from the UE to eNode B1 telling the eNode B to do that it happened. Another aspect over here is that if the UE has decoded security mode command and RRC connection reconfiguration, and then it went into RLF, then it will try RRC reestablishment here. So that in that case, it will be the scenario which happened in the previous slide, and it will be pegged under RAN initiated ERAB setup failure. But once the UE has an RLF, a radio link failure, before reading these commands, then because the UE has not activated the security mode command, it cannot do an RRC reestablishment. So it will have to set up the connection from the start. And for that one, it's an RRC connection request, and that is why in this case it pegs under the MME induced failures and not under RAN induced failures, even though the issue is still a RAN or radio issue. So this is why the MME induced failures in many networks are actually radio interface issues and not MME issues. So we should actually be focusing on the radio part rather than the MME part. Now how to improve that? Again, this is something related directly to radio quality. So you can optimize to improve your radio quality, or you can of course also change your N310, T310, increase them to reduce this number of RLFs as well. That is also a possibility. But again, the important and the root cause again for this is radio quality. So it's always preferred to improve your or optimize your radio quality when you have this kind of issues. Okay. Another one which is difficult to analyze, but it is there in many networks, and it is not really possible to find it out from the KPIs itself. You need a trace for that, but let me just try to explain or make you understand what this issue is. This is called a paging conflict. Now consider this scenario. This UE sent an RRC connection request, MO data, mobile originating data, and then the eNode B will set up the RRC with RRC connection setup, and then RRC connection setup complete. RRC is completed over here, and then the eNode B will send S1 initial UE message to the MME. MME sends S1 initial context setup request, and the eNode B will peg ERAB attempt over here. Now after this, the eNode B will send RRC connection reconfiguration plus security mode command to the UE, and that is how the call flow works. Now consider this scenario that before this all of this started, or during all of this is going on, there was an S1 AP paging message for this UE. Now if you know MME, whenever it gets a paging, it will send it to the eNode B, but the eNode B will have to wait until the next paging cycle for the UE. Because let's say if a paging cycle is 1.28 seconds, the UE will actually wake up every 1.28 seconds to read the paging. The E node B cannot just send it as soon as it gets the paging message. So let's say E node B gets the paging message for this UE and it waits until the timer has stopped, right? And then once the timer is up and the paging cycle is up, it will send the RRC paging message to the UE. Now, if this paging message is sent to the UE before the ERAB setup has been done, the UE will think that it needs to respond to this paging message and it will just go back to RRC connection request saying empty access. Empty access is the response of RRC connection request, mobile terminating access. It is the response to the paging message. So the UE, the same UE, will leave everything here, go back to RRC connection request, sending an empty access in response to the paging message, and based on that the E node B will set up a new RRC setup because the E node B does not know, E node B does not have information about the UE at TIMZ level. So even though it's the same UE, the E node B will not be aware that it is the same UE because E node B does not read the TIMZ for any decisions. E node B gives RRC CRENTI as an identifier when it's talking about all of the UE's transactions. So it will set up a new RRC setup, a new call for this UE, and when the E node B will send S1 initial UE message to the MME for this UE, the MME will think, okay, I already have an established session or an ongoing session for this UE over here, right? So it cannot have two active sessions for the same UE. So it will respond with S1 initial context setup request to the MME to the E node B for this UE, but also send an UE context release command for the previous session. Now the E node B does not know that these two calls are for the same UE because it cannot read the TIMZ, and it will actually think that the first call has been rejected by the MME and it will peg it as an ERAB setup failure induced by the MME, and it will continue to proceed with the RRC reconfiguration and security mode command and the ERAB setup for the same UE but the second call. So what's happened here is that due to paging conflict, we have created a scenario where the UE has initiated two calls on the same E node B, and the E node B is unaware that the two calls are for the same UE, and it releases the first call thinking that the MME has sent an ERAB setup failure, and it will continue to go and proceed to set up the second call. So from the UE's perspective, there is no real issue, but from the perspective of the E node B, it will peg an ERAB setup failure for the first call, and we will have a problem, right? So if you look here, the blue ones, these are call 1, and the red ones or the maroons ones, these are call 2, but they have the same TIMZ. So in both the scenarios, what we can say is that the call log, both have the same calls, both have different calls but the same UE, and we have a problem on the first attempt. So in this case, what we can do is that we can initiate something on the paging cycle. If we have a smaller paging cycle, then this time that paging buffered in the E node B will be reduced, and if this is reduced, then the probability of this issue will also be reduced. So moreover, also there are I think with the new addition of UE and new software upgrades, there are chances that this will be reduced as well, and once that happens, we can also see an improvement in ERAB setup success rate. Now from the perspective of call logs, how can we find out this issue? Now if you have an ERAB setup failure, and if you look at the RRC connection request, it's MO data, and then you look at the next RRC connection request for the same TIMZ, if it is empty access and it is before the UE context release of the first call, then it is most probably caused by a paging induced issue or a paging conflict. I repeat, this is a bit difficult. So if you have an MME induced ERAB setup failure, and you want to find out whether it is induced by paging conflict, then the best way to do that, check the RRC connection request type. If it is, let's say, MO data or MO signaling, or MO data mostly, and you see that it is failed by the MME, URI context release command by the MME, and then you see that for the same TIMZ, the next RRC connection request is empty access, and that one is before URI context release command of the first call log. Then it is caused by a paging conflict, and this can actually be reduced if you have a smaller paging cycle. But of course, smaller paging cycle will have other problems as well that we will discuss in the paging mechanism for the LTE session. So okay, that's all for today. I hope this clarifies lots of ERAB setup success rate KPI issues, and I hope that it helps. Thank you so much. Stay tuned, do subscribe, and we will continue with more LTE KPI optimization sessions. Thank you so much.